Okay, so we're going to start out by manipulating algebraic expressions. And this first algebraic expression we can actually solve, whereas these other two we can't because they're not set equal to anything. If you want to attempt this first equation before I solve it, go ahead and pause the video now. But we're going to launch right into it. So the first thing I would do in solving this equation is to multiply both sides by 3. Because by multiplying both sides by 3, since I know this side is equal to this side, I haven't changed the fact that they're both equal to each other. Since something multiplied by 3 would equal that same thing multiplied by 3. And so here we're going to get 27 times 3, which is 81. Now, I'm going to add 9 to both sides, because as long as I add the same thing to both sides, I haven't changed the fact that they're still equivalent to each other. And now I'm going to divide both sides by 6, and that will do the same thing, which is to keep them both equal while changing the values on the right and left, and we end up with x equals 15. So we're able to solve this equation for x equals 15. Now looking at this equation here, we're just going to simplify this. It's not set equal to anything, but we're just going to simplify it. So we have 3xy minus 9y over x minus 3. And I see an opportunity in this top formula to pull out, and that should be x minus 3. I see an opportunity in this top formula to pull out 3y, because both sides have 3 up here and both sides have y up here. And so what that would look like is I'm going to do a distribution. So I'm going to distribute 3y times x minus whatever I would need to multiply 3y to get this, which is negative 3. And so I end up with that on top, and I have this on the bottom. Now, since the top and the bottom both have x minus 3, it's basically just multiplying 3y times x minus 3 over x minus 3. And that would be equal to 1 here, so that's going to cancel out, leaving us with just 3y. So this whole formula was just equivalent to 3y, and we got there through distribution. Now, doing the reverse here, I'm going to basically FOIL, and if you're not familiar with this concept, it's something that goes by many different names, but FOIL is the way I learned it back in the day. So that means multiply the first terms. So we're going to multiply the first terms here, and that's going to give us 27xy. So in multiplication, order doesn't matter. You can multiply these together and then keep the x and y multiplied all together with that. So we multiplied the first. Now we're going to multiply the outer. And the outer is this one and this one. They're on the outside. And so we're going to have positive 3x times x, which is going to give us positive 3x squared. Then we're going to do the inner, which is 9y times negative 4, which is going to give us negative 36y. And finally, we're going to multiply the last, which is negative 4 times x, which gives us negative 4x. So this is what we get out of the equation. And this is just another way of looking at this same representation. Now, the GMAT a lot of times will give you information in the least usable format, and they will, or a less usable format, and they'll want you to reorganize it before you start doing math. So it's really important to be able to manipulate algebra, to look at it differently, because it'll help you see what they're actually looking for in terms of an answer.